Okay, so we're going to process the exact same way we processed question number 1. We're going to go through and figure out our hints. And, yeah. Okay, cool. See ya. Good luck. I probably won't see you I'll see you guys when you guys can show up for your exam. But you said you're not coming tomorrow. Okay. So, a student has 2 test tubes, one containing prop and one all. So, again, we want to annotate it. So, what function group is that? Alcohol.
We know this because of the O, right?
It is primary because it's on carbon number 1. So, if you want, you can specify it's primary. Propanol, how many?
3.
Prop.
3.
Wait.
Prop.
Yes. My bad. 3. I'm just testing you.
Oh, no, you're making me doubt. I'm like, no.
I don't know. I had 5 in my head for some reason. Baby brain, okay? We can't trust me right now. All right. One containing prop and one all. The other containing prop and 2 all. So what do we know from that?
Secondary alcohol.
Secondary alcohol. And then how many carbons? 3. Okay? Okay. A student adds acidified potassium permanganate to each test tube and warms with water. So we need to know what potassium permanganate does. We also need to know what color change it does. There's lots of things we can grab about potassium permanganate. And in fact, it says describe the color change. Okay, so let's go look at our resource sheet. You guys are going to have this memorized by Friday?
No.
I'm going to have this memorized by Friday.
Like only memorize some of the.
Well, you're just going to have to do it. Just flashcard, flashcard, flashcard. Like, seriously, because you need to be able to know what this does. Yeah? Okay, so potassium permanganate is this one that's purple. Okay? Yeah, so it says purple to colorless when heated, and it has primary alcohol and secondary alcohol and aldehyde. So what we should expect here in both of these test tubes, color change wise, with that potassium permanganate, is that we're going to go from purple to colorless. So both will be purple to colorless. Because we know potassium permanganate changes from purple to colorless if we have an aldehyde, a primary alcohol, or a secondary alcohol. And from what we've been told up here, they both fit those conditions. Okay? Cool?
Mm-hmm. Let me just.
Yeah, okay. You okay?
Yep. No, you're good.
All right, so the next thing that it's asking is explain how Toland's reagent can be used to distinguish propanal and propanon. So let's go through and annotate. So propanal is what?
Aldehyde.
Yeah, good. And propanon is what?
Ketone.
Ketone. All right, and then we're going to look at what Toland's does. So again, we have to memorize what Toland is. So if we go, I told you guys. All right, so if I look for Toland's, I see Toland's reagent, silver mirror or black precipitate. So what we see is a silver mirror forming. That's my observation, and this only happens with aldehydes. So I go back here, Toland's, the silver mirror, only aldehydes. I like these pens. These are good pens.
Come on.
Gotta love them.
Oh, no, I'm lying to you. That's Yo-Yo Sew.
Hmm?
That's Yo-Yo Sew.
Yeah, so.
Yeah, my old company I got for free.
Oh, so I can't buy these. That's what you're saying.
No.
Oh,
But hey,
bummer.
you can have them.
No. You take them. I have my own. I'm just like, these are nice. I have my.
Work with it.
Yeah, it's like my felt markers, but I do actually like this tip on here. It's actually a nice tip. Okay, so when we look at our marking schedule here, you see for the achieved, correct observations for both alcohols, which are for colorless, and then it says or, so there's an or option here. You just got to do it once. Correct observations for Toland's reagent identifies oxidation reaction, which is something we forgot to do. So we got our observations. We didn't talk about any of our products, but that's okay. Type of reaction we forgot to answer. If I'm going from an alcohol to an aldehyde, that is oxidation. So we just got to memorize those ones, unfortunately. Okay. Luckily, we wrote this down here too, so we can get it. So either or of these correct. This is an or option. That's your achieve point.
We don't have to write any like statement.
You should. I'm just annotating it. So I would say you should write a full sentence. This is oxidation. You should also write silver mirror. Aldehyde will go form a shiny mirror on the test tube. Something like that. Okay? So it's an or option. Obviously, write more complete sentences than I am. But I'm showing you the annotation process because the annotation then helps you then scaffold your answer. Yeah? Okay. Keep going. All right, we're on 7 now. Now we're starting to get into some of the nasty questions. Not nasty, this one's not the worst one. I'll show you which one I mean that I want you to skip. Because it's not worth you trying to figure it out. I photocopied them hopefully correctly. What are you doing? That's the marking schedule. We're still on this.
Oh, still same page. Great. Amazing. Because I was confused. I was like, oh.
Okay, I know you guys look at this one and you're like, I hate this one, which is fair because it is yucky, but if we look at the achieved, what they want you to do is identify 2 correct functional groups or features. Don't even figure out the molecule. You're on question 3.
Oh, my bad. Oh, I was on question 3 too.
Did I photocopy it wrong? No? There you go.
Oh, sweet. Thank you.
Okay, so 2 correct features on it, focus group or structure. So you don't actually have to figure out the molecule. If you see here, it's merit level to get the molecule.
Okay.
So don't stress. I don't know if that helped or not. Okay, here's my formula. Not a whole lot of help to me in general, but we can use some of the properties that we talked about with spec in here. Maybe not so far. We'll see. I can't remember. Let's read the whole question first. Okay, so we have this information here about the formula, and it says that it can exist as a number of different constitutional, also known as structural isomers. So basically, we're talking about molecules that can have the same formula of this, but they might be bonded differently. They want you to draw the structural formula of the isomers, and they've given you this here, and then they have the properties given to you as well. We're not going to be focused on drawing the structure, because that's the merit stuff. Okay? We're just going to be annotating stuff that we know and writing it down. You guys are welcome to stay. Okay. So the first thing it says here is that it's going to be a straight chained molecule. So straight chained, and we can start annotating our notes here so we can get our points. Straight chain, what does that tell you?
No. Yeah, no methyl as well.
No methyl, no ethyl, none of that. So no branches.
Oh, yes. That's
Yes,
the word. That's the word.
Okay?
Yep.
It can exist as enantiomers. So we need to know what our word enantiomer means.
Optical.
Optical isomers, which mean, like, what is the requirement to have an optical isomer?
Chirocarbon.
Yeah, so enantiomer tells us it must have a chirocarbon.
Which means 4 different things.
Attached to one of those carbons, all right? Turns damp blue litmus red. So blue litmus turns red. What does that tell us?
It's a
Blue to red.
I don't know.
I'm gonna actually draw these as arrows instead of equal signs. This is why we got these guys memorized. Blue to red. What functional group would do that? Don't look.
Amine.
Close. Carboxylic acid.
Oh.
So blue to red, carboxylic acid, because that's an acid. Reds are acids, blue are the bases.
Okay.
Yeah. Also, when you look at the formula here, you don't see anything that has a nitrogen. which would be an amine.
Oh.
Gonna need some of our spec knowledge. All right, blue to red, so that tells me that it has a carboxylic acid. All right. Rapidly turns bromine water from orange to colorless. So we need to, again, memorize what bromine water does. So what does that tell us? Again, we got to memorize these guys. So we're looking for bromine water. Yep, so you see, rapidly decolorizes bromine, and it says rapidly. So that must mean it's an alkene or an alkyne. Cool. If I stop here, the marking schedule says 2 correct functional groups or structural features. That's a structural feature, that's a structural feature, that's a functional group, that's a functional group. So I have given me 4 answers. I only needed 2. You're already at an achieve because you've just identified things about the molecule. You haven't actually drawn the molecule. Okay? So this one here goes, a molecule that can undergo hydrolysis in acidic conditions to produce methanol or another organic molecule that exists as cis-trans isomers. So, that's a weird question. What are you talking about there? Oh, I see. That is a nasty question, but I can see that one. All right. So this one here, the hint to this one is that it can undergo acid hydrolysis. Okay? So there are 2 things that can do hydrolysis. Or sorry, I would say 3. There's polyesters, polyamides, dipeptides, and esters. So there's 3 things there. First off, I look at that and I know it's definitely not any polymer because there's only a set number of atoms. All right? So then it's either going to be like a dipeptide or an ester. Now, it's not a dipeptide because I see no nitrogen. So what that tells me? Ester. So if we can do acid hydrolysis, you then tell you that this is an ester. And that's all I can really tell from that. There's not a lot of hints there. So this one really kind of depends. This one really wants you to find the molecule. But we can still note that if acid hydrolysis is occurring, the molecule must be an ester in this version 2. Okay? And like I said, 2 features. You had 5 features you could have commented on. You don't have to worry about knowing how to figure out what these molecules are. That's the merit, that's the excellence. We see in the excellence, it is 2 correct features. It's 2 correct structures. So this is an excellence level question, but there are things you can do for the achieve, and that's what I'm trying to show you. Cool? Mm-hmm. All right. Keep going. All right. This is one that I noted here. So if you look at my list here, we talked about knowing our definitions, like enantiomers, knowing how to do simple conversions, so just the first or the last step. Identification tests obviously come up multiple times, even though they're not identification test questions per se. Knowing the vocabulary, again, hydrolysis. Now we're moving on to this section here, that questions that have the answers in them. So this is ones that have the answers in the question themselves. You just have to know how to break it apart. Okay? And that's what I said. You need to know how to break apart and put together. And this is what you were working on, Melania. So this here, you see how you have a dipeptide? This little son of a bitch is coming back. Yeah? So you have a dipeptide here, and what they're asking you to do is draw the structural formula of the 2 amino acids that are used to produce that dipeptide. So all you need to do is split it here, because we know that's where the amide is. So all right, so you cut it here. Now you see how on this side here, that's the carbonyl. So carbonyl gets the alcohol. I'll keep recording it. Okay. And we can always do this tomorrow too. All right, so the carbonyl. So when we're doing hydrolysis, we are taking water, H2O, and we're using that to break up a molecule. When I use water to break up a molecule, one molecule is going to get the hydrogen, the other molecule is going to get the OH.
Okay.
Okay? So the carbonyl end is going to get the OH. OH.
Okay.
And then the amine half, which is that one here, the nitrogen, gets the hydrogen.
Okay.
So all you gotta do is break the molecule apart, stick the OH on this guy, stick the hydrogen on that guy, and you have the answer. So if you look here, it has the answer on the schedule. You just have to make sure you copy everything down here as well. This is what I'm saying as an example of the answers in the question. And then 2 correct structural formula for the amino acids. So if you can break this apart and then add the OH and add the hydrogen, you get yourself an achieve point.
Okay.
All right? The other thing you need to do, because there's an and here, which I really don't appreciate, is that they want you to identify the type of reaction occurring.
Wait, do I have to draw this down into?
Yeah, so basically you copy this down and you show it as 2 separate molecules.
So it should be like the carbon.
So you do the carbon, the hydrogen, the CH3, you just literally copy it from above. And then the only thing that you do that's different is you see you have the C double bond O. Now all you're doing to this guy is you're just adding the OH.
Okay.
You're literally copying it from above. That's what I'm saying. The answer is literally in the question. And then you copy this guy down here, and the only thing you change here is instead of saying NH, you say NH2.
Okay.
Okay? I won't write it down because it's going to say what's So the other thing you do for the achieved is identify and explain the type of reaction. For the achieved, all you need to mention is that you know what's happening. So in this case, if I am taking these 2 amino acids and putting them together, that is condensation.
Mm-hmm.
So putting the amino acids together is condensation. You heading off?
Yeah.
Okay.
Is it the website you're talking about?
Hold on, let me pause this recording. Let me see what you're looking at this for. Yes.
Okay.
Yes. And I don't know if they have it for the level 3s. I don't think they do.
Oh, that's the level 3.
Yeah. But I don't think they have it for level 3. I would take the OH and I would take the hydrogen. That's why we call it condensation. If I was doing the reverse and I was breaking it, that's hydrolysis. So you're taking water to break it. Hydrolysis. Hydro is water, lysis to break. Okay? So that's just a definition thing. So just memorizing your definitions. This one was also crazy, silly, because it was just saying, draw the structural formula of the 2 products from acid hydrolysis of the dipeptide. So what that means is they want you to draw this.
Oh, sorry. Your charger was in here.
Yeah, I forgot it.
That's right. And I don't want to do it in silence.
That's fair. All right. So this one here, it says it wants you to draw the structural formula of the 2 organic products from acid hydrolysis of the dipeptide. So what this is actually telling you to do is to draw these again in the acid. Okay. So then what this means then is we need to copy this guy over and then think about what happens if I put it in an acid. So the thing to keep in mind is that if you have an acid, I'll change the color. So if we have acid, so in an acid, the base gets neutralized. So in this case, when we're talking about acid base in organic molecules, we're talking about the amine.
Mm-hmm.
All right? And then if it was in a base, And that's going to be your carboxylic acid.
Can you see instruction shortened? Like carboxylic acid?
You can write CA, that's what I do.
But then obviously when I
Not on the exam, though. Yeah. So the thing is, we have to think about what does that mean stepwise. So if in this step here, if my base is getting neutralized, we are adding a hydrogen. If my acid's getting neutralized, we're removing a hydrogen. Okay? So I copy this molecule down. I look for the amine, and I go, amine gets another hydrogen. So I write, instead of NH2, I write NH3, and then I put a little positive sign.
positive.
Yep.
Yeah.
So basically, you write this exact same molecule. See how these are the same molecules?
Mhm.
The only thing different is that this has an extra hydrogen, and it has a positive sign.
Brilliant.
And that's it.
Okay.
Propanate's one amine group in one of the molecules, you get another achieve point. So you see how they're giving you 2 achieve points for the same answer?
I have a question. Is you
Yeah.
know how I write like not like this, but
Yeah.
like the fully
Yeah.
spread out? Is that okay?
That's
Or-
fine.
Okay.
Yeah, just make sure you have the right count.
Okay. Okay. To be like,
Yeah.
that's not right, girl.
You know what's also crazy? Is that if you had both of these written down and you propanated both of them, that was a merit point. Yeah. I'm not going to bother copying it down because you can do that on your own. Does that make sense?
Yep. Sometimes what I did here.
Yeah. So then you write your N. Yep, there you go. And then you can do a little plus sign and you're done. That's another achieve point.
Brilliant.
Isn't that easy? Easy. Yeah, so since this guy up here is requiring you to draw both of them, then you just copy both of them down again and just add an extra hydrogen.
So because it's amine.
Yeah.
Amine, it just adds a
Yeah.
little hydrogen.
Yeah. If I was dealing with this in a basic solution, what I would do is I would drop the hydrogen off the carboxylic acid and just write a negative sign.
Okay. Cool.
Okay? This question comes quite a bit with both the amides and the esters. So if I had an ester, the alcohol is not acidic or basic, so it's unaffected if I'm in an acidic or a basic solution. So I just leave the OH alone.
Okay, cool.
And then this one only changes if you're doing it with a base solution. If you're dealing with an acid solution, you leave it alone. So it should be hopefully a relatively straightforward. And that's the end of that question. So this one was an achieve point, that one was an achieve point, that one was an achieve point, and that one up here was an achieve point. So there's 4 achieve points. So again, that's the A4. All right. I'm happy to go through the last question, or you can call it. I think the last question should be relatively quick.
I somewhat understand this because I did this a little bit with Sanders.
Yeah. All right, I'll stop it and record it again.